Hi, my name is Willa Kent, and this is my lab for oscillation. Introduction. Purpose. Examine the motion of a mass oscillating vertically on a spring, and understand and predict oscillating motion using fundamental principles. Analysis. Compared predicted motion with observed data using Python and Tracker, and plotted the energy changes occurring in the system for the predicted motion. Preview. The observed tracker model and the predicted Python model share similarities in the x and y axes, and the change in total energy is 0. Key concepts: net force on an object, velocity update formula, position update formula, energies, and the energy principle. And on the right, you can see an image of the springs and the forces acting on them. The tracker model. The system is the earth, spring, and mass, and there are no surroundings. If the system is set to include all elements that do work on the system, then the work of the surroundings is 0 and the heat is 0. The video FPS is 0.095 seconds per frame, object mass is 0.402 kilograms, start time is 0 seconds, initial position is negative 0.648 in the x, 0.135 in the y, and 0 in the z. Initial velocity is 0 all around meters per second, and the final time is 9.947 seconds. And I have a picture of the spring in motion and of the charts of the time and direction. Here is my Python code with all the initial conditions. And here is the Python code of the computational loop. Discussion. Change in energy versus time graph. As the change in spring potential energy increases, the change in gravitational potential energy decreases accordingly, both lines crossing the x-axis at the same time. Position versus time graphs. While both graphs show a strong resemblance to the actual and predicted data, the predicted data is more accurate regarding the actual data in the x direction. Potential error. The excluding of other sources of energies, i.e. thermal, rotational, etc., other sources of non-accounted for friction, i.e. drag, and errors regarding the placement of the data point when trying to track the center of mass. Discussion questions. Is the energy principle satisfied? According to the graph yielded from the Python code, the energy principle is satisfied. At any given point on the graph, if the energies were summed, the total energy would be 0. The oscillation between the change in gravitational energy and the spring potential energy is the easiest way to see how the energy principle operates. With any increase of the gravitational potential energy, there is a decrease in spring potential energy. Estimates of oscillation periods. Average oscillation period x position is 1.519 seconds. In the y direction, it's 1.633 seconds. The difference is 0.303 seconds. The difference between oscillations has an impact on spring force, spring potential energy, and the calculation of the spring constant. This difference can be caused by drag, incorrect tracking of the center